The last major impact that we're going to look at of human activity on the ecosystems of the Earth in general are greenhouse gases and global warming. One pressing problem caused by human activity is the rising level of atmospheric carbon dioxide in the air. You've probably studied in middle school science or some of your other science courses in high school about greenhouse gases and the greenhouse effect. And of course, I wouldn't want to tell you that all greenhouse gases are bad. Certainly for Earth to harbor life, we need a certain number or an amount of greenhouse gases in our atmosphere to hold our temperature in a certain level. Without those greenhouse gases, without the atmosphere that we have, the Earth temperature swing would be quite dramatic, and during the night it would be extremely cold, during the day it would be extremely hot, and you would have some of the variances you see on other places like the Moon and Mars and the like. So greenhouse gases to some degree are necessary for life on Earth up in our atmosphere. The problem becomes when those greenhouse gases, the amount of them grows, and so the heat trapped within the lower atmosphere of the Earth and the Earth itself begins to rise. And you've probably studied this before. You have solar radiation that penetrates into the atmosphere. Some of that is reflected back into space, but some of that is also transferred into thermal energy, heat, as it hits the Earth and then re-radiates back into the atmosphere. The more greenhouse gases you have, the more re-radiation of that heat back and forth between the Earth and the atmosphere you get, and the overall temperatures begin to rise. Same way it works inside of a greenhouse that your mom or your dad or your parents have if they like to raise orchids or other sort of tropical plants. You can have a glass or a plastic greenhouse outside even in the depths of winter here in Texas, even though it may not get too cold, but still 20 degrees or 15 degrees is too cold for a tropical plant, and it might be nice and warm inside the greenhouse due to this same effect. The glass or the plastic allows the radiation to penetrate but not the thermal energy to exit, and so that raises the temperature there in the greenhouse. Due to the burning of fossil fuels, you have to imagine what are fossil fuels. Fossil fuels, of course, are the remains of ancient plants and animals. It's a carbon storage system. So during the Carboniferous period that we kind of looked at earlier in the semester, you had these giant plants that prior to the rise of decomposing organisms such as fungi and the like, you would have these Carboniferous plants that would die off and fall and would become buried over time, and those became deposits of coal. And then you also had phytoplankton in the oceans. As they died, they sank toward the bottom and were compressed over time. They became these deposits of oil and natural gas that we use. So you have all this carbon basically stored within the Earth, and now when we pull that coal and oil and natural gas from the Earth and burn it and use it, we're releasing that carbon back into the atmosphere at a very fast clip, at a high rate. So the concentration of atmospheric CO2 has been steadily increasing with our use of these fossil fuels. Now you may hear that why would that be bad? Because certainly plants need carbon dioxide, so if you increase the carbon dioxide, you're going to benefit the plants, and that just makes for a happy atmosphere. Well, it's not quite that simple. Yes, some plants will benefit from this increased carbon dioxide, but it's not just a simple that means it's a good thing. Most plants do grow faster when CO2 concentrations rise, but remember there are different kinds of plants. We talked about C3 plants and C4 plants, and so some of them are affected differently by the growth or the rise in the amount of carbon dioxide. C3 plants are more limited by CO2 than C4 plants, so you may see kind of a proliferation of C3 plants, and that may begin to crowd out other C4 plants. So it's not just a simple yes, plants need carbon dioxide and thus somehow this is a good thing. It's obviously more complex, as all biology related questions are. It's never a black and white, this is the answer, and that's as simple as it gets. This is a good graph that shows you the increase in atmospheric carbon dioxide concentrations in the Mauna Loa Observatory in Hawaii and average global temperatures. Way back in 1958, in this observatory or this monitoring station in Mauna Loa, Hawaii, which is a great place because it's not directly impacted by a lot of industry quite around it, so it gets a good sample of the overall atmospheric conditions. And so what they've done is they've been taking observations or measurements of global CO2 over time since the early 1960s, the late 1950s. And so you can see in blue the steady rise over time of global CO2 concentrations. The red would represent the average global temperatures over time as well. And of course, you do see variation. Throughout Earth's history, there have been variations and sometimes pretty high spikes up and down. So we have ice ages and we have warming trends, and yes, the overall heating and cooling of the global temperatures is certainly a part of the natural phenomena of the Earth. But what we see in the short amount of time since the Industrial Revolution, we have seen kind of a dramatic upswing in rise in overall temperatures, overall global temperatures, and that tends to coincide with this CO2 release into the atmosphere. Your textbook has a good example of some of the study that a conservation biologist might do regarding this release of carbon dioxide. They have what's called a FACS-1 experiment going on, where they basically have these forest plots and the ability to control the amount of carbon dioxide within certain areas of that forest plot. They use these devices that pump out carbon dioxide and kind of maintain the carbon dioxide level at certain particular levels that the scientists want, so they can do tests and run accurate measurements. And so they're looking at how does that affect the different plots. And in the CO2 enriched plots, it did produce more wood than the control plots, although less than expected. And it shows that CO2 is not the only thing that affects tree growth and production. Of course, it's much more complicated than that. You also have to figure in the availability of other nutrients and sunlight and nutrient uptake, things of that nature. But it's a cool way. It's one cool way that scientists are looking at how is the effect of rising carbon dioxide going to affect the environment over time. Is it beneficial? Is it not beneficial? What's it going to do? Here are those plots and the devices that they have to kind of maintain certain levels of carbon dioxide in this large-scale experiment. So this is just a cool example of what conservation biologists do regarding this particular topic. All those gases that we're talking about, carbon dioxide, water vapor, methane, there's many of other gases that would be considered greenhouse gases. They reflect infrared radiation back toward the Earth and cause this greenhouse effect that we talked about. And of course, I already mentioned that we want some of this greenhouse effect to keep our atmosphere and to keep our Earth of a certain temperature, to keep it habitable, but this increasing concentration of CO2 has been linked to increasing global temperatures over time, and that's going to increase a wide number of things. That's going to increase water evaporation, which is going to increase water vapor in the atmosphere, which is going to then increase global warming more. So it's a positive feedback loop where we have pumped large amounts of carbon dioxide into the environment. That begins to raise global temperatures, which then causes more water vapor to be released, which raises global temperatures, which begins to melt, say, ice floes and icebergs in the poles. And those icebergs are nice and white and reflective. The land underneath is dark and absorbs more temperature and more heat, more thermal energy, more radiation. So when the icebergs melt and they reveal dark land, that land absorbs more thermal radiation, re-radiates that back as heat, and so you have this positive feedback loop that's feeding in on itself, and it's kind of the tipping point is the addition of the carbon dioxide due to man's activities. One good question to ask is, how do we know about the past? How can we say that this is not just a part of the normal patterns that the Earth would see over long spans of time? Well, we use a variety of data to take a look at that. Climatologists make inferences about past environments and their climates. And of course, this is an inference. We weren't there and we can't say for sure. But remember, basically all of science is an inference. We're talking about probabilities. You may say that we can infer that the sun will rise tomorrow because we know how the Earth turns and what the patterns are. But of course, you would never say you're 100% sure. That is not how science works. It works off probabilities and inferences, and once the probabilities are so great, you would be silly or foolish to not accept that as fact. So climatologists make inference, of course, about past environments, and they use a variety of sources. Pollen and fossil plant records reveal past vegetation. CO2 levels are inferred from bubbles that are trapped in glacial ice. That would tell you the carbon dioxide concentration from thousands of years ago. Chemical isotope analysis is used to infer past temperature as well. So it's not one piece of data or one piece of evidence, just like with, say, evolution, the study of evolution. There are multiple streams of evidence that confirm this idea or confirm this hypothesis. Northern coniferous forests and tundras show the strongest effects of global warming, and so if you want to look and see where things are happening due to global warming, you look at these northern coniferous forests, the taiga, the tundra, the extent of ice flow, the extent of ice formation in the poles, the melting of glaciers and the like. For example, in 2007, the extent of Arctic sea ice was the smallest on record since we've been taking records, and there's a quick little link right there if you want to check out that article about the extent of Arctic sea ice. Of course, every summer the Arctic ice shrinks as it melts and then refreezes in the winter, but over the past 10 to 20 years there has been less and less and less ice refreezing in the winter, and the long-term frozen ice has begun to melt more in the summer. A warming trend would also affect the geographic distribution of precipitation. So you would expect more water vapor in the air because the air is warmer. You would expect a little bit more unpredictable weather patterns, shifts in weather patterns, perhaps more tornadoes or more hurricanes or different amounts of precipitation in different areas. That's what global climate change is all about. Change is the key word there. It may be beneficial in some areas, but it may be detrimental in others. At the very least, it's going to be change. So that's what we need to be prepared for. Many organisms, because of the rate of change we're talking about, may not be able to survive such a rapid climate change. Of course, we know that species adapt and evolve over time, and they have adapted and evolved over the thousands and millions of years of the various natural climate changes of the Earth. We also know that many species have gone extinct due to various climate changes. But if the climate change proceed at a more rapid rate than biology can keep pace with, that's when you're going to expect extinction to become more likely. One of the ways that organisms deal with changing environments is to move to a more suitable area through migration. And some ecologists have even thought about or supported this idea of assisted migration, which would be the translocation of animal species to a more favorable habitat beyond their native range. So you might even want to consider in the future, we might consider even potentially assisting the movement of creatures into more suitable habitats, because as climate conditions change, as global temperatures change, the shift of the most favorable habitat is going to occur, and we may find that some of these creatures can't make that change fast enough to avoid extinction. Of course, there are things we can do. I would never want to think that this is inevitably hopeless. There are things that we can do to help stabilize the situation, although I had just recently read reports, and you may have heard recent reports in the news that say things like the loss of certain glaciers and ice sheets in the polar regions has become almost inevitable, that by the time that we turn things around or change things, there's already going to be a certain amount of change that is already in motion that can't be stopped. So that is concerning, but certainly there are things that we can do. We can slow the use or reduce the use of fossil fuels, try to convert to more environmentally friendly energy sources such as solar and wind and the like. And all of those have problems. It's not like we're just going to be able to snap our fingers and go from fossil fuels to solar energy. Certainly there are hurdles to overcome, but in the long range planning, I think those hurdles are obviously well worth the effort over time. I mean, the sun presents basically an unlimited energy supply if we can develop the means to capture and use that energy, as opposed to, say, burning oil or natural gas or coal or something like that. So stabilizing CO2 emissions is going to be hard. It's going to require international effort. It's going to require change on the part of many people. Recent international negotiations have yet to reach a consensus on global strategy to reduce greenhouse gas emissions. In the United States, if you just watch any of the political news about the United States, this is still a very contentious issue. But I will tell you, amongst scientists, it's not such a contentious issue. It is a political issue, not a scientific issue anymore. Reduced deforestation would also decrease greenhouse gas emissions because trees act as carbon sinks, taking in CO2 and incorporating it into their structure. So the loss of tropical rainforests just makes this problem worse, because trees, of course, take in carbon dioxide and they incorporate that into their bodies, basically trapping that carbon dioxide into their bodies and keeping it from being in the atmosphere. So fewer trees means less intake of carbon dioxide. So that's just a continuation of the problem that we're talking about here. Last but not least, along with all the scientific things that we've discussed in biology class in 1306 and 1307, I would always ask you to please seek out reputable science-based information. A lot of these subjects, which would seem to be science-based subjects, they become very politicized and they become all about society and politics and psychology, and very much not anymore about science. And this is a good example. There is a legitimate reason that the vast majority of all climate scientists, those scientists who actually specialize, practice, and publish within the field of climatology, agree that climate warming trends over the past century are very likely due to human activities. There's a reason that climate scientists are saying what they're saying, and it has little to do with politics and who's going to be the next president or who gets voted this or whether you're Republican or Democrat. None of that is science. So on a scientific subject like this, I highly urge you to look for reputable scientific information before you make any sort of decision about the subject itself. Just a couple of quick links here. I could find you 1,000 links, but here's just a couple of quick ones about the scientific consensus of what global climate change means and what it's due to, and then here's some evidence for that information. Again, I just chose these because they're easy ones to find and they're reputable scientific sources, but I would encourage you to find those reputable scientific based sources for your information as opposed to, say, political talk shows and things like that. Alright, so we're going to stop right there. Global warming, climate change, ozone depletion, loss of habitat. Yikes, man, what a bummer. It makes us sound like we are a horrible species, and in many ways we have done a lot of bad things, but we're going to try to wrap this up with a little bit more positive talk. So our last little section here will be a bit more positive, and it'll be about maybe one of the things or some of the things that we can do to change things. Concept 56.5 says sustainable development can improve human lives while conserving biodiversity. So we're going to try to end on a more positive note. We'll come back and do that in just a second.